Login accepted.
Hello and welcome, Devoxx Poland, to our talk called Avoiding Mistakes with Events, one event at a time.
While everyone is coming.
There's plenty of seats. Float in.
Prepare tomatoes, if you're ready.
And good toasts.
Good stuff. Why we wanted to talk about events?
Because they are eventful.
Because they are eventful.
Or in a bit more honesty and more down to earth, we've been working with systems that mention events in this form one way or the other for many years. And we've seen many patterns, and we've seen many patterns of failures, or many patterns that will eventually lead to failures. And because we're locals, we really like to rant or just mention things that sometimes go suboptimally.
I would say the best postmortems are usually mentioning an event, right? So it's one of the cases. Okay, but a question, what is an event? So I think, I bet it's one of the most overused words now. So we wanted to actually have a chat with you about what is an event.
So rather than asking every one of you in turn, because that would take a while, let's quote Mr. Fowler. Everybody knows Mr. Fowler. Mr. Fowler, this is everybody, now you know each other. So, Mr. Fowler, in his blog, there is a link at the bottom, has identified a couple of event types. The event types that he identified are, first of all, event notification. Something notifies something that something changed. Hey, Wojtek, I'm here. Come to the stage. Let's do a talk.
Okay.
Then
that wouldn't be an event, right?
Actually not. What would you gain? You gain low coupling, but you might be hiding the flow in something that hides between the lines.
And we will come back to that.
Then there is another type of event.
If it carried state transferred, right? So
I think that's quite self-explanatory.
It's quite obvious. So you're basically sending the whole state change from one system to another systems. So the whole idea is to reduce latency and make sure that all the systems will be synchronized with the source system without actually additional operations, right? There is a third type that he mentions.
Is event sourcing. Or how we can define it for the need of this initial part of the presentation is state changes are transferred as events, and state is reconstructed from events. And I think that's enough.
You probably have seen this talk. He mentions the fourth event type, and that was a surprise to me, because that's CQRS. And even on his blog, he says, that's not an event type, but it's used with events, so let's mention it during this talk and during this in this blog.
So
we'll come back to that.
We've read an article from Mr. Fowler. We're all experts now, so maybe let's introduce ourselves. My name is Andrzej Grzesik. I know that in this audience, most of you can spell it and say it properly, and that's a victory. I work in LMAX. If you know, you know. If you don't, it's an exchange in which we use Java and we count microseconds and nanoseconds. And apart from that, I do various bits. I like improving systems, those based off protein, those based off silicon. I do things, I identify with some icons.
My name is Wojtek. I'm actually from here, from Krakow. I live not that far away from here. So great to welcome you to my own city. On a daily basis, I work with Revolut Business. I'm responsible actually for Revolut Business on the technology and engineering side. So if there are any bugs, you can actually talk to me after the talk. In another room, there is my co-partner in crime in the CTO Morning Coffee, so our podcast. I think we did like over 60 episodes now. So there is actually a good library of stuff that I really wanted to discuss with people wiser than me, and I tried not to kill myself on different occasions, let me put it this way. And with that, we really wanted to say all opinions are ours.
So we do not represent any specific companies or organizations. All the mistakes are because of us, and we're sorry.
That's a lawyer's note.
Well, we have to. You know the reality. So, why talk about events? Why talk about data? Because somebody, or specifically Mr. Clive Humby, if you heard about him, he's a mathematician and an entrepreneur in the data space, let's call it. He said that data is the new oil. And if data is the new oil,
then events are the fuel. And actually the whole world, of course, now uses events, and they become integral part of our design of our systems and how we work. And with that, Andrzej, I need you
let's try to see if this works. So there is a survey. The website
pick up
is
your
called,
phones.
You can pick up your phones.
Dear audience.
You can use a QR code, or you can go to menti.com and type in a number and answer the first question. I hope this works, and we'll see if it works, because yes. Where are you?
If Alberto is in the room, I think that, yeah, you are here. So you can pick up one of the answers.
So answers are flowing in, and that means that Wi-Fi works, which is an amazing thing at any technical conference. Congrats to the organizers. So intermediate, beginner, advanced, and expert. And I think we have 100 votes plus. I think that's good. So most of you are either intermediate or beginner, which means how you can use this talk very directly is if you see a pattern in your workplace that we mention and you think something is off, talk to your colleagues. Feel free to email us as well. And talk about that, because that might mean that you're running into a problem, or maybe your context actually makes it something else. So,
with that, we wanted to actually build on the event. If I say an event, it would be interesting to ask you, what do you think? What comes to your mind first? Because when we actually discuss it with Andrzej, there are so many meanings of the word event. And therefore, there are so many understandings of what do I mean when I say event-driven, and therefore it drives a lot of our decisions and discussions within our teams. And with that, let me introduce the first type of the event that we believe exists in our systems. It's audit log. So basically speaking, it's a chronological record of everything that happened in your system. Basically speaking,
user logged in.
Yeah, you basically speaking maintain a full historical trail of everything what happened in your system. It can be, for instance, logging very important information for you in your system, right? So logging attempts, maybe for compliance reasons. I work in the bank. We need to log pretty much everything. So that's a typical audit log, and that's an event as well.
If you work in e-commerce, you have a customer service team. Maybe they will be recreating the journey that the customer had on the website or within your company through a log of events as well. So that's what they do. Then there is another type of events, notifications. We mentioned them before. We actually like the name, so we'll borrow it. Notification is something which is lightweight, and it's used to notify that, hey, something happened.
It's very lightweight by design, and the whole idea is, oh, I know that it happened, so I will fetch additional data, whatever I require from any systems that I need. And that leads to interesting problems later on, which we'll touch on.
You would use notifications, as Wojtek said, too. The couple, Let's move on. Event carried state transfer. This is very self-explanatory in the name. But what that means that we cannot count on synchronous state. Because an event will be delivered, and then when somebody reads it, well, then they are aware of the new state. And because the event carries the state transfer, then you don't need to call somebody else. You don't need to query other services about what's in there, because everything arrived in the event. It's like a very well-equipped cargo train with everything that you might desire.
But the fun part is that when you use it, or maybe overuse it, your system becomes more and more eventually consistent. Because by design, event carried state transfer, is eventually consistent, of course. So that can lead to interesting problems.
And, synchronized state, if you have a big system with a lot of moving parts, it's going to be a bit of a problem. And then you have to replicate, then you have to manage that, and then devil hides in the details. We'll come back to problems later. So now let's move on to another type of events, something that we call domain events. Domain events do one thing. For your business entities, or domain objects, they capture and express facts about those domain objects. Shopping cart was updated. An order has been submitted, payment was initiated, and so on and so on.
And they're not used for integration, which is an interesting part that is very often forgotten about. I'm speaking from experience working with different teams. So you do your orange stickies across the whole room. You know exactly what is your domain, what are your domain events, and then you publish them on Kafka. And that leads to interesting problems down the road, which we will actually touch on. Okay, an event can also mean event-driven architecture.
Because we have events in our system, which means, of course I'm doing that, right? Well, an event-driven architecture, we would call it something that where events are the driver, the fuel for a system to act. Depending on how far you go, you can see it in databases, networks, CPUs, everywhere. But for the business systems that we usually work with, an event arrives and then some action happens. It's not that something else provokes that change.
And it's designed to, of course, the whole idea, sorry, not designed, but the whole idea is we design loosely coupled, scalable, and reactive systems, of course, right? So that's very useful in the modern systems and architectures. And there is event sourcing, if you think about the event, right? So coming back to folders list.
Event sourcing, as we described, the state of the object is taken, sourced from the events. Then, because event sourcing gives us, then there is another thing, which is called
event streaming, that I worked with for a couple of years. So basically speaking, you can process events on the fly, so react in the system before we even persist events, right? So a good example, a real example, Uber gets a stream, or while you take a ride, gets a stream of your geolocation, of your accelerometer, put it on Apache Flink job, and that checks for collisions. So if there is anomaly, it will on the fly react with additional event collision happened. And there are some specific types when we discussed it with Andrzej, when we brainstormed it. As you can see, that was quite an evening. So what are some specific types that I think I saw working with the teams, and you can tell me if you agree. Lifecycle events. So you invite domain experts into the room, you give them sticky notes, and you tell them, tell me how it works. And there is a very important, of course, entity, and you want to capture the whole life cycle of this entity. And you want to make sure that you capture all of the events, and they're important for you to capture the whole life cycle of the aggregate. So, again, that's very useful when you use event storming to design your systems.
And as I'll come back to that. As you see here, this is about order created, order paid, and so on. So business nouns and business verbs, not about an object was created, object was updated, and deleted. This is not a CRUD style of conversation. This is the meaningful verb conversation.
A subtype of events, which I have seen, is saga events. So they're designed specifically to manage the saga. And we'll come back to them because they might be quite useful, actually, to make sure that we avoid one big problem in the system, right? So typical events to manage your distributed workflows, in other words. But, okay, so we introduce all of the events. The important thing is when we discuss events, as you can see, is to understand what do we mean by an event, and then, of course, apply the right patterns to what we're going to build. So just to recap, there are many meanings of an event, and we want to propose 3 categories. So different event types as patterns, so event logs, notification events, event carried state transfer, domain events, and lifecycle events. There is an architectural style, and there is event processing. In many books and many talks, that's mixed up. And that's what leads to confusion.
And also, when you work with people who wanted to do something, events, because maybe they went to a talk and they really wanted to do that, and they maybe listened about CQRS and they are trying to apply the patterns absolutely everywhere, there's nothing wrong with learning. But that leads to interesting problems. Also, as we build the systems, our understanding of the problem space that we're dealing with changes. So we learn that the problem that we thought actually fits that pattern very well might fit a different pattern very well. Or maybe we've added so many steps along the way that we have to change. And
with that, we've got time for the second survey. So if you go to our...
Oh, it's already filled in. That's amazing.
Okay, thank you. For people who want to actually reply to the second question.
We have definitely a winner. The winner with no prizes is notification events. Then we have domain events, and they are getting votes, and then people are saying thumbs up, thank you. Thumbs up to you back. Event carried state transfer, that's something that is quite popular.
Less popular than I thought, but still.
Some event sourcing, some event stream processing, and some others. And I think that actually matches what we expected.
What we thought.
Notification events and domain events are very popular. They are the most popular, which means probably, just by applying this statistic to your workplace, probably you're going to encounter them most often. Event sourcing, even though it has a place probably in every single technical conference that happens this year, is in the minority.
Not that popular.
It's not a problem. It's absolutely okay not to do event sourcing. You can use this as a quote to in your workplace. It was said that we don't have to. So, what's the conclusion from that? Well, the conclusion is when somebody says, hey, let's build a system with events.
What can happen?
Which one did you actually mean? What do you want to do with that? And how do you want to process them? And for what purpose?
And you see what's coming. If you have been to my talk a year ago, we were doing a system design interview. So let's say we're doing a similar job now, a very similar system. So we want to design a system for a person to pay for their goods in e-commerce store. So basically speaking, our actor here is the person who bought the present, and there were somebody who will receive the money. So we're building a financial application.
Oh, let me try. So I want to build it on the internet. So I definitely want a web application, because that's what people are going to interact with. I don't want to build a mobile fat app, because that's, well, complex. Well, web should be okay. I'll need a load balancer. I'll probably want Redis, so that it can be very quickly received and stored, and it will not be lost. And then probably I'll need a payment service, and I'll put it into PaymentsDB, and it will be okay, right?
Then the interviewer asks, how will you store the transaction?
Oh, it's very easy. I will have an additional service, one called Ledger, one called Wallet. Ledger is going to have all the money movements, so that we have everything. This is where money movement events are going to sit in. Wallet is going to have state changes on wallets. And
which is a representation of your bank account, basically speaking.
And then if I have to do something else, maybe there is going to be some caches because, hey, I will buy in euro and somebody wants to charge me in zloty, or vice versa, or it doesn't matter. And I will need to record to know what's where, also because the business people really want to have those fancy graphs of currency changes. And I think that's good, right? I'm passing the interview so far.
How will we ensure, then, that we monitor transactions? For instance, for anti-money laundering or bad actors, how do we make sure that we send notifications and so forth? So a bit advanced features.
Oh, it's easy. We put Kafka and we use Kafka.
We publish events.
We publish events, everything that subscribes to those events, and this will magically work, right?
Right, almost. Okay. And then usually, if you have time, the interviewer asks you, what can you do else with this system? Okay, let me show you. Magic. I can do real data stream processing. We will be monitoring for, there is, of course, the famous word, behavior analytics. So we will be able to target whatever things we want to target and so on and so forth. So basically speaking,
we'll be doing stream processing, so we'll be doing anomaly detection on the customer behavior, and then we'll notice if they have some different patterns of behavior, maybe to use security or maybe to propose different items for them to buy.
So usually, really, the conversational system designs interview goes this direction. And then there is a question. What can go wrong in your system? So, are you happy with the design? That's a real question that people will ask you.
Thumbs up, thumbs down. So far, we're good.
So, who's happy with the design? Let me come back. Come on.
a few Polish smiles in the audience, but yeah, we're in Poland, we expected that.
Let me tell you, there will be dragons, like real ones.
Well, for an interview, for a story, it makes perfect sense. In isolation, it makes perfect sense. The problem is, there is a lot of fire built in, and there is a lot of heroes that are going to be grown, and some of them will burn out, and some of them will run away.
And actually, some systems will burn.
What we have here is we have distributed processes. We are not mentioning how we handle any failures. We all say that, hey, this is going to work, load balancers are going to be great, Redis will not change their licensing model, Kafka is going to scale infinitely and it's going to be very cheap, even though we put it in a cloud provider.
Let me point to the account owner and how many notifications of the payments he has received. He's a happy person. He's saving for his Porsche. The Porsche is coming. The question is, are we sure that's exactly what we wanted to show, right?
But phones are getting bigger. They support a whole screen of notifications.
With that, let us take you to mistakes with events. So there are a couple of categories. Let's review them.
So,
what can happen with the audit log?
Starting with audit logs, which you already are familiar with, their purpose is to be able to tell a story. Somebody who wants to recreate what happened, they want to read the logs, they want to read the events, maybe do it through a website, maybe do it from whatever, and they want to understand what happens. If they only log the action that was performed without any contexts, obviously this is going to be a bit difficult history because you have to then query other systems. If you have to query other systems, you're not asking the other systems about the current state, you're asking probably at the state at the time of the query, or about the time about which you are querying about, and that becomes difficult. And then if you bolt it on and bolt it on and bolt it on, it's hard, and it's complex, and it's
And in some businesses, let me tell you it's real, you may have very difficult questions from auditors why something happened. So that's a real problem.
Recommendations, why did we recommend a particular item to a particular user? That's a very popular e-commerce kind of question. If you want to evaluate whether the recommendation system is treating people fairly. It cannot be a black box, it cannot be magic, it cannot be AI. It has to be, this is based on that and that criteria, and we're not discriminating anybody.
Problem number 2, we're storing sensitive information in audit logs. So it happens very often. So basically speaking, if you remember the days of Hadoop, it was a big problem before GDPR, when GDPR came. Actually, we needed to redesign our systems because we had so much personal information in our logs. There were whole companies built around removing personal information from audit logs, especially big data systems. So it happens very, very often.
PII, that's sensitive information. PII means personal identifiable information, emails, anything that GDPR will be interested about. Payment industry has a category of data like that. Anything to do with, for example, payment or card processing.
Cards numbers.
That's going to be covered by those regulations. And if your company deals with that, you will be audited.
Absolutely. What can you do? You can mask or encrypt, of course, any sensitive information and store them externally to the audit log itself.
And the conclusion to between the lines here is sometimes there might be a lawsuit against the company which will say please purge all the details about X or Y from your systems. And they don't care that it's on the blockchain or in Kafka or whatever solution you're using. The information has to be there no more. Make it so.
A very interesting type of a problem that comes with notifications from my perspective is every single company has at least one service that actually uses its own events published publicly. So it consumes its own events. So it's very interesting what happens there. So we're using integration events to drive our own logic, in other words.
I sometimes send myself emails when I want to remember about something, but that's an unusual situation. There are pieces of software that cannot call the appropriate method, so they send an event and hope for the best.
It will definitely lead to very tight coupling, so it will definitely lead to problems of implicit logic, which we'll come back to. And the way to refactor out is reconsider why are you using events, then maybe implement other asynchronous communication patterns. So you can use queues, maybe, not necessarily events. You can reconsider using CQRS to make sure that you actually fully separate, of course, the different concerns.
Or maybe your service is just too big. Maybe it should
or
be
maybe
two.
your service is very too big. With, actually, implicit logic comes very interesting problem. So notifications are very, as you can see, very popular. And they introduce a very interesting problem. They're very easy to use, right? We have the system that we publish events to, something gets these events, they do something with that, and the whole flow starts, and there is actually the whole workflow, a business process that is fully distributed across multiple services with notifications.
And it's very easy to do because you add one more, and then you add one more, and then a product owner, manager, whoever that is for you, comes and asks, can you add this and that and that? And you keep saying yes, because of course you want good performance reviews at the end, and hey, business wants to make things happen. And soon you end up with a maze.
With implicit system. So I would say, think why you need it, if it's needed, introduce process managers. Let me show you the...
Let's have an example. So we have a payment service, we want to...
send some notifications,
so
and we introduce, of course, some Kafka. Then somebody says, oh, we can integrate with that as well. And usually it grows like, oh, we can integrate with that as well. And that's usually how our systems grew into this problem. When you actually analyze the whole workflow, of course, you will tell me it's an obvious workflow, but hands up, if you haven't got a single workflow that it works exactly like that, it should be explicit, but actually it's modeled using implicit notifications. And you don't necessarily know exactly what's going on in the system, what is the order, what should be the order or the workflow, etc., right? So that's ideally it should look like this, but because it's a notifications event-driven system, for instance, of course there will be all of the problems with failed deliveries, multiple deliveries, and so on and so forth.
Okay, then. We'll come back to that example in a second. With so many interactions, we will run into a problem with interaction events, or it is possible, or sorry, integration events. They will happen. They will try to integrate something, and then they will fail to do is capture context. They will fail to capture the time, not a timestamp, but what timestamp specifically is being meant there. They will not mention order. Hey, I'm an event, you're an event. We go through the different brokers. Is the order, does it matter? Does it not? Sometimes it's not even explicitly specified. Or some people just prefer to say, I'll use one partition in Kafka and I will practice hope-driven development. Processing a payment received, is it possible before an order placed? Does it make sense? What should happen if you see that? Is it a global failure, so any payment process before order received is a problem, or maybe only in the context of a single customer? There is no global right or wrong here, because it's going to follow the business process that you're trying to model, but timestamps, be specific. Event received, order, information.
Can you use the example?
Yeah, actually I should show you code. An ID, an explicit status, and a handler. And then, of course, this is an oversimplified example, but hey, we can see if this is a sequence, and we're doing that in a sequence. And if something is not in a sequence, hey, we don't do it. We probably want to notify, or we wait and notify if we're doing that, I don't know, 5 minutes after the original event. This will get very specific very quickly, because if you're doing real-time system monitoring, you will want to react quickly, or maybe not. If you're doing something that involves a national mail operator and physical processes and people doing things and delivering physical items, hey, maybe days are going to be your frame of reference.
An interesting problem that I already mentioned is when you publish your domain events. By definition, domain events belong to a bounded context and they're internal. So if you're going to publish them, there might be interesting some problems happening. First of all, your ubiquitous language, so your internal language, your semantics will leak out, and systems will be coupled to your internal ubiquitous language.
And then the ledger team wants to change the representation of how they store money movements, and they can't because the whole company relies exactly on that interpretation and however they publish. Of course, what will happen is they will introduce an intermediary API and they will do some translation and you will get out of that. But it's a mess that maybe can be avoided because directly publishing is sometimes not great for the internal events. If the event is in the belly of the system, don't publish it. Somebody will say, no project has ever failed because I've put Hibernate annotations on an event and I've published that. But if you're doing that, then nothing stops you from publishing the internal state too easily and too quickly.
Especially that it will contain sensitive data.
Yes.
Because that might be the whole reason why your domain exists and it operates, for instance, on the sensitive data. So what you can do is consider other integration patterns and, of course, introduce a layer to publish events with a so-called publish language, right? Another problem that we often see when working with domain events is overloading domain events. So I'll show you an example. Order updated event, right? We wanted to go beefy, and we wanted to model that we updated the event, and it's so easy to add a couple of more fields. But what you can see here is actually mixed responsibilities. So when you see something like that, and these examples, by the way, are especially designed to highlight problems, so your issues might be a bit more subtle and gentle. Here is, for instance, the clear refactoring, right? So we can have different events for or the status change and price update.
And looking at this, hey, but nobody would ever make this. Yes, but those events are not created, or those situations are not created. Let's do it very badly. Let's make the biggest JSON event possible. This is added one line by another line, team by team, week by week, and then you end up with a ball that keeps growing, and then suddenly your broker explodes because it's out of disk.
Oh, come on. It will take 16 megabytes, right? Per event. Okay, event sourcing. So for event sourcing, I would recommend watching any Oskar Dudic presentation, especially the latest one, how to design the worst event sourcing system. But one that we really want to highlight is not considering so-called long-living streams. So basically speaking, an event that, an aggregate that will actually have a very long history. A very perfect example would be a bank account, right? It has so many events that needs to be aggregated from the very beginning to recreate, for instance, the current status. It leads, of course, to degradation of the system, degradation of any operations that are dependent on it. So what we can do is, of course, use snapshot.
How it materializes if somebody in your team mentions that, hey, in order to start the service, we have to query the whole event store and apply all the events every single time, and after a year still we have to do 1 year, after 2 years we'll have to do 2 years. This sounds insane, but people still try to do that.
A common problem is wrong event granularity. Sorry. So what I really liked when I heard it, CRUD sourcing or property sourcing, right? So two different ways to do it. So I would say not all of your orange stickies should be an event, right? So basically speaking, remember and understand why actually what's the purpose of the system and what is how you're going to operate on these events, how are you going to process and store them. So basically speaking, fine-grained events, they increase complexity, higher network load, performance, overhead, etc., etc. So that's the big issue. But coarse-grained will actually combine, as we've seen, unrelated actions, unrelated responsibilities into a single event. So but as well, as always, remember to balance. So here is an example: too many events, and of course there might be gazillions more. Of course, the other way around would be just transaction process event. Maybe in your system you need one or the other, but be mindful about what you're doing. Okay, what about when we have events and we want to evolve them.
Well, that's a technicality, but you've seen it. What is in the event? Hey, just check in Kafka or open Kafdrop and see what's there. Okay, but what was there a year ago? How did it evolve? Which version of the event are we looking at if we're browsing historical records? That information, should be explicit. So store schema. I know whichever JSON framework you're using, it's very convenient to just annotate the event and ship it, and it will work. But then, if you have a test that tests if you can resuscitate such an event from JSON, and it can also take the old format and still make a representation of the event if you're going to use it, then that's going to save you from problems. Semantic versioning for event schemas, you've heard of semantic versioning. This is nothing new. Schemas, like in the database, well, we want to make them explicit. Also, that means that if I want to integrate with another team, Wojtek has a team, I have a team, even though we work in a different company, we want to integrate something. What is the API? For REST, that's easy. We'll use Open API or whatever Swagger is called today. For events, go figure it out. Well, not really. There are tools for
cloud events, right?
Cloud events,
Avro.
Avro in the worst case, but yeah, still, it works. Version numbers and tests for backwards compatibility if that's going to happen in your system. Simple unit test, can I inflate the string and make it into an object?
And a bit of chaos engineering, but we'll touch on it as well. Okay, another problem that we very often see, very often I would say, a lot of postmortems, is not handling and not designing for actually failures, right? So the event may not come, the event may come out of order, and so on and so forth, right? So remember, whenever you use events, make sure that you build in a retry mechanism, exponential backoff, and dead letter queues. So that can be very handy. A true story, make sure that you understand how much your dead letter queue can take, because that can happen that you will feel dead as well. So that's a very interesting postmortem.
Similar spirit of example, assuming events will always be applied. Sometimes they will not, because maybe the database is hitting hiccups. And then what should happen with that event? Should we just keep going forward and lose information? That is a choice in some systems. Sometimes this is a choice that happens unintentionally. This should be handled, and this should be, well, there is no other way but to think about it and address it in whatever makes sense in your problem.
Not delivering has a different side. Delivering too often.
Or
too
delivering too many, because there is no exactly once delivery in computers. Don't trust me, trust Byzantine generals. Idempotency is a solution, or explicit checks if we think that we've handled an event. Use event IDs. If you're going to use event IDs or some other idempotency keys to make sure that you want to apply that event yet again, that's going to help. But then you will soon come into a problem in which, is that really an idempotent event? Is it, do I want to schedule 2 bank transfers? Or is it because I clicked because I like clicking? Or is it because my browser is having problems with itself and it actually sends to post requests? There is no trivial answer to this. It is going to be context specific. One thing that helps with delivery guarantees is naturally the outbox pattern, so that you are
sure that
shielded from hiccups on the broker side.
An inbox pattern on the other side to make sure that you received and process only once.
And the moment you have an inbox and outbox, there's the same problem like when you come back from holidays. Your mailbox is going to be full of things. You want to monitor that.
A very trivial example. So again, excuse trivial examples, but this is especially to show you, for instance, that we want to send a notification to a person that has sent money or and is going to receive the money. And of course, we don't want to send too many notifications, not to cause headaches. So a very trivial way to do it is actually implement something like this. And this will ensure that you're not sending notifications if they were already sent. With a bit more advanced problems, which we often very often see. So
we at Kafka, we don't monitor. It has to be monitored. We always learn it the hard way. Size of a queue, rate, size on disk, but also individual events among different queues. Is there a story that we want to connect them by? Then that means you know the answer, trace ID. There were good talks about monitoring. I know that Michał did one today, and observability, or will. But there are materials. Michał is an excellent expert to talk about. I recommend him because I know him, so absolutely that. There are other people who know their stuff in that area.
And interesting is correlation ID. So of course, if there is a workflow and there are different events produced during the workflow, you can use the same correlation ID. Super easy to trace what happened and when and where exactly. And especially if you have a system like this, right? Because
this is what's going to, under the hood, eventually evolve. The problem is it's not going to be explicit unless you dedicate some time to that. And discovering problems in a sea of invisibly connected nodes is hard.
And you can imagine that actually having a workflow that started. So for instance, let's say that we start this payment and it's event-based. And you actually probably down the line, you will touch half of the system. Having a thing like correlation ID may help you greatly with designing, because we should design for the unknowns, as Chris said. Two interesting types of events coming also, as you can see, coming to the topic of workflows and event-driven distributed operations.
You remember this picture, so you don't have to read it, because the exact words don't matter that much. We've added colors. What is here between the lines is there are 4 distinct phases of this workflow, of this process, which means if we put fire under any of them, okay, thank you for demonstrating the fire, what breaks? If it breaks here, something will not happen. If we don't pick this up, notification will not be delivered. That's not a big deal.
And it happens very often. So let me tell you, if you have a system that has workflows, how often do you need to debug, if it's event-driven, debug inconsistent states, or for instance, customers calling you, hey, I'm waiting for your response for the last 2 weeks. So it will happen. And how to prevent that? I would recommend something that we call Saga timeout pattern. So basically speaking, whenever you have a long-running transaction, you are designing the system in a way that it will inform you about the timeout that something hasn't happened after a given event, but it should have. It's very easy actually to implement. So basically speaking, you can do exactly what I said, but in the code, right? And it will help you to be to get unstuck with any process.
And it's also a very good and useful thing to put into monitoring. When we have a payment processed, we want a matching event with that correlation ID happen within some window of time. If not, raise an alert or make Nagios, I think, or any of the more modern solutions go orange and then go red and signal problems. Because, hey, this is a hidden problem, and we want to be aware of it when we want to make it explicit. If you're signing up to an e-commerce site and you don't get the sign-up email, well, you're kind of stuck, because you might try to sign up again, and they will say, hey, you already have an account, you've not confirmed your email, and if you don't get the email, well, tough luck. That kind of process, without some explicit steps or idempotency, so you can request the initial email many times, will lead to stuck processes. And it's funny when we're talking about a website. It's less funny if there are huge amounts of funds being involved or large groups of people, because they will go trade elsewhere.
With that,
you know this already, so
maybe you even answered our third question.
Let's see what happens there. What's the hardest? The hardest is failure handling, monitoring debugging.
Distributed transactions.
Distributing transactions.
I knew it.
Yes. One thing that is between the lines here, scalability, as much as I love it, as much as we all love it, doesn't seem to be winning. It's designing transactions, which means handling failures and thinking about preventing those failures and allowing the fancy failures from not to happen, because some of the simple and surprising will always bite us anyway. Handling of those failures, monitoring and debugging. This is the same kind of spirit. I would say that data consistency belongs there as well. And then I would say, in my opinion, my interpretation of that is then event design, schema evolution, Maybe overusing maybe overusing events is another group of, let's call them grapes.
I wanted to come back to one slide that we omitted.
Let me take over then and click around.
So one thing, if you say that distributed transactions are really, really hard, I say, why are you using distributed transactions? And I mean it. So very often we overuse event-driven architectures when we don't need them. So one thing that I wanted to suggest is, if you have a Saga, for instance, a process manager, the colors here also have second meaning, because you can mix synced and unsynced. You don't have to do everything event-driven, right? You can have a service that actually takes care of a given workflow and does a number of steps synchronously whenever needed. Okay, with that, we had your answers. So let's review our system. You remember it very well. We had all of these problems. A couple of things that we can very simply put, and if you have a situation like this, first of all, please don't design such a system, and hopefully you don't work on such a system. If you do, try to simplify it step by step. For instance, what have we proposed? Payments process manager, if we really want to use some event-driven distributed workflows. So to make sure that, as we said, we can take care of any timeouts, we can actually monitor the process, we can roll back these processes, and so on and so forth. We also introduced some maybe outbox and inbox patterns here and there, and we changed a number of calls from, we changed a number of workflows from asynchronous to synchronous.
I'll say it from here. Not all calls have to be asynchronous. It's okay to make a sync call. You can feel all right. You're not doing anything completely wrong if you do that. The rule is that there is no single rule about how to build a system correctly, because your problem space will have to drive it. That will give you context, which means talk to your colleagues, argue, make design sessions, and maybe not hope for the best. Because if you're doing events, and you have a system that's actually complex, let's say a couple of teams working on it, using events and driving everything by that is not a place for a here and now mindset. It will work out. Yes, until it doesn't. If somebody tells you that, hey, we don't have to make that decision now, we don't have to make that decision now, we don't have to solve this problem now, and keeps working like that, you can already feel what's going to happen. Don't let that happen. Signal problems, have checks, and because that's going to keep you awake at night or maybe during the weekends, and there are better things to be done. With that, let's move on to
closing takeaways. So first of all, understand what an event is and what it means. I think we missed a lot by the fact that we were introduced with only 4 types, which, by the way, one of them wasn't really an event, and a lot of conversation went wrong from that moment. So hopefully our introduction of different meanings will be much more helpful for your discussion. So be specific when you discuss it. Understand different patterns and what are the different purposes.
If you're trying to solve a problem, figure out which one you're dealing with, and then, yes, they will all be called events. And the fact that you've just called something an event, the next one is going to be an event, the context will dictate which pattern of conversation you want to apply and then use that. Match the problem with the solution. It's not that we have to do notifications or fat state carriers everywhere. There are no points for being very consistent but wrong system. The points are for building the correct, and it's a pleasure to work in a nice system that doesn't have some problems.
Make sure that you design your events mindfully, right? So remember about versioning, remember about schema evolution from the very beginning. Remember why are you actually analyze and understand why are you using events. Why do you want them to contain the given information? Is it really needed? Do you want to go this direction or that direction? Remember about the storage, about network, and so on and so forth. So you need to be very careful. You will get it wrong in the beginning, But the whole idea is, of course, you can evolve, and I mean, you have to evolve, right? Hence, also remembering about all of the evolution patterns that we need to apply to events.
Learning is part of the process. As you've expressed something with events, if it doesn't fit the reality half a year or a year later, it can be changed. If it breaks consistency or how the system is done, because everybody wanted to do it in one way and then you want to do something else, it's okay. And something very good in this geography, be pessimistic, assume things will go wrong.
Apply Polish smile.
And design for failure. What if this goes badly? What if that goes badly? What if this doesn't get delivered? Or if things get mixed or twisted in order, and so on and so on. This is the attitude to have here. As much as we might come across joking, sadly not.
And monitor and observe. So learn how to build distributed systems, learn how to monitor them, understand how you can, if you have these workflows, especially given how many notification events you said you're using, understand how to track them, how to track their life cycle, how to make sure that you understand where they are, because they lead to very ambiguous bugs, very long debugging in your systems. With that, we wanted to recommend a bit of reading as well.
Those are great books.
Probably you know them.
Level your desk, raise your monitor, and actually get a lot of useful facts out of them. If you like reading on paper, then they should be available in most e-shops to be delivered. If you like reading digitally, then it's trivial.
And some talks, we can definitely recommend them. With
that, we're going to say thank you very much. If you want the slides, drop me an email with feedback. If you drop me an email with feedback, you'll get the slides back. Very easy. Thank you so much. Enjoy.